All right, so we have made it to Chapter 1, Lesson 9, Direct Variation. And this lesson is found on page 81. All right, our real world link says the distance y a car travels after x hours can be represented by this equation. Y equals 65x. The table and graph should also represent the situation. Okay, now I want you to circle this because this is something we're going to learn about, equations that look like this and the graphing and the coefficient. We're going to talk about that. All right, fill in the blanks to find the constant ratio. So on this problem here, you're going to refer to the graph to get your answer. Distance traveled. Well, 2 has 130. 2 hours, 130 miles. Now, 195 miles will have 3 hours. So you put a 3 under that one. Now, what will go above the 4? 260. You get this information from the graph. Any questions on how to fill that out? All right, let's go on. The constant ratio is blank miles per hour. Well, 130 divided by 2 is 65. 195 divided by 3 is 65. 240 divided by 4 is 65. And if this had an exact number, it should be a 65. All right. Now, number 2. The constant rate of change, which is another name for slope, of the line is change in miles over the change in time. Here we have our change in miles, 195 minus 130 over 3 minus 2. So we have on top it's y minus y and x minus x. All right? Do you see how they're doing that? Okay, so we end up with 65 over 1, which is 65 miles per hour, which is also in this equation, that is your constant rate of change. When you have something set up like this, y equals 65 times x, what you are multiplying in front of your x is your constant rate of change. That's very easy when you have formulas like this, then you don't have to do anything. Write a sentence that compares the constant rate of change and the constant ratio. Well, they are the same. Yes. Okay, so now let's go to page 82. Direct variation. What? They're all very similar. Yes. Some similar names, some of them mean the same thing, some just use the slope. So let's just talk about this here, direct variation. And we've got some equations here I want you to look at. A linear relationship, that means a straight line, is a direct variation when the ratio of y to x is a constant, k. We say y varies directly with x. All right, let's write this down over here. So, y over x equals k. That's a formula that we're going to be using. What's this? This is the direct variation. A linear relationship is a direct variation when the ratio, this is the ratio of y to x, is a constant k. So the ratio of y to x is the constant k. We say y varies directly with x. Now, this is the more popular use of this equation. You're going to see y equals kx. These say the same thing. let me show you how this turns into this. If you have y over x equals k, and I tell you, you have to solve for y. Well, the first thing you have to do is undo dividing by x, right? What's the opposite of dividing by x? Multiplying by x. So you multiply by x, you multiply by x, and you end up with y equals kx. See how this turned into that? All right. So, and this is the more popular way of saying it. When they refer to this formula, in the book, you'll usually use this one. Okay, so here we end up with the example y equals 2x. Let's see how they have that. So we've already figured this out. Y equals 2x. So here, y, whatever y is, it's 2 times x. So your value for x, if you take it times 2, that gives you the value for y. We're going to practice this so it makes more sense to you. All right, look at all these yellow words. When two variable quantities have a constant ratio, their relationship is called a direct variation. The constant ratio is called the constant of variation. The constant of variation is also known as the constant of proportionality. This is the one you're going to hear more so than the constant of variation, the constant of proportionality. Okay. Now, in a direct variation equation, the constant rate of change or slope is assigned a special value, a special variable, and it's k. All right, so it's going to be assigned a special name, and the special name is k. Let's look at some examples. Once we do this, it gets better. Sometimes all these words make it sound complicated, but it's really not that hard. The height of the water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. Okay, since the graph of the data forms a line, the rate of change is constant. Use the graph to find the constant of proportionality. All right, so in 5 minutes, it's 2 inches. In 10 minutes, it's 4. 15, it's 6. 20, it's 8, and so on. So here we have, you put your rise over run. So you put what goes this way, that y is 2 over 5. That equals 4/10 per minute. So it goes up 4/10 per minute. 4 over 10, the same. They all equal 4/10 per minute. So the pool fills at a rate of 4/10 of an inch per minute. Okay, now let's go on and do letter A. 2 minutes after a diver enters the water, he has descended 52 feet. After 5 minutes, he has descended 130 feet. At what rate is the scuba diver descending? Okay, so in this problem here, he has descended 2 minutes. So 52 divided by 2 equals 26. So at what rate is the scuba diver descending? He is 26 feet in 1 minute. Okay? 26 feet in 1 minute per minute. Now, just to double check, will we get the same if we have 130 divided by 5? Yes, it also equals 26 feet in 1 minute. All right, before we go on, there's a direct variation between these two. When a relationship varies directly, the graph of the function will always go through the origin. Also, the unit rate is located at 1r. Is that an R or a V? 1V, I think, is what they have. And we'll talk about that later on. Okay, let's go to page 83. Here we have an equation, y equals 10x. It represents the amount of money y Julio earns for x hours of work. Identify the constant of proportionality. This is so easy. The constant of proportionality is the 10. You don't have to do anything. That's why you like it. If you get your equation in this form, the number, which is called a coefficient, in front of the x is your constant of proportionality. Isn't that easy? So if it looks like this, whatever's in front of the x is your constant of proportionality. All right, the constant of proportionality is 10, so Julio earns $10 for every hour that he works. There will be a question about that on your quiz tomorrow, so make sure you know what a constant of proportionality is. All right, let's do letter B. This is very easy. Identify the constant of proportionality. Okay, what's the constant of proportionality in letter B? Yes, 55. Now, we have to explain what does it mean.
It means he earns $55 an hour.
Well, they're traveling in letter B.
Oh, no, yeah. Well, 55 miles
Per hour. Yeah, the Chang family is traveling 55 miles per hour. I'm just going to put the Changs instead of the Chang family. Changs are traveling 55 miles per hour. Okay? Any questions on that? All right. So if you have something set up like this, you know the constant of proportionality would be a 3 in this one. Okay, you want everybody good at that? Put a happy face if you know what constant of proportionality is. Now we're going to determine direct variation. Not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions are direct variations. Okay, so pizzas cost $8 each plus a $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? Okay, we don't start at the origin here because you're charged $3 for delivery. So right then it starts right there. It's at the 3, I think is what it is. So 1 pizza will be 8 plus 3 is 11. 2 pizzas will be 19. 3 is 27 and 4 is 35. All right? Now it says, you see how they got those plotted on the number line or in the graph. There is no constant ratio and the line does not go through the origin. So there is no direct variation. Okay, do you get that? Why is there no direct variation? Does not go through the origin. That's the origin. It doesn't go through there. And there is no constant ratio on these. Here, 11 divided by 1 is 11. 19 divided by 2 is not 11, is it? No. 27 divided by 3 is 9. 35, so their unit rates are not the same, are they? No. So it's not. So when the unit rates are all different, this is 11 over 1. This will be 9.5. This is 9. And that is 9.25. They're all a little different, aren't they? Yeah. That one's the best deal right there. Oh, that's not 9. It's 8. 32.75. All right. Any questions on that part? Let's do letter C, and you're going to graph it over here. 2 pounds of cheese cost $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. Is there a direct variation? Okay. In this one, And let's see, 4. Okay. Now, and 0 pounds of cheese will be $0. Now, is there a direct variation? Are all of our unit rates the same? Yeah, they all will equal $4.20. Does it go through the origin? Yes. So then it is a direct variation. Why? Unit rates equal the same. Are the same, and it goes through the origin. Any questions on that? So you're going to write this whenever it's a direct variation. This is what you have to do to say justifying. Why? Unit rate's the same, goes through the origin. Got it? A lot of times it's not going to be because it doesn't go through the origin or it makes a crooked line. It's not a straight line. Okay, because the unit rates aren't the same. Let's go to page 84. Determine whether the linear relationship is a direct variation. If so, state the constant of proportionality. Okay, so the constant of proportionality is like the unit rate. Got it? Okay, so compare your ratios to check. 12 over 1, 24 over 2, check. 36 over 3 equals 12 over 1. 48 over 4, check. So, since the ratios are the same, the relationship is a direct variation. And the constant of proportionality is 12 over 1. Any questions on that? Okay. And if you did this, y equals 12x. Okay, let's check. Is this true? Y equals 12x because our constant of proportionality is 12. Does 12 times 1 equal, so if your x is 1, 12 times 1 is 12, that equals your y? Yep, that's going to work. We always just double check your formula. Let's do the guided practice. Okay, what is the ratio of cakes baked to hours worked? Okay, in this problem here, 1 hour it looks like is what, 50? Whoa, 20, no, it's 30. Excuse me. 1 hour is 30. What is the ratio of cakes baked to hours worked? It's 30 cakes in 1 hour. Any question on that? 30 cakes per hour. You could also say that in this one, 60 divided by 2 is 30. You could get it that way too. Number 2, an airplane travels 780 miles in 4 hours. Make a table and graph to show the mileage for 2, 8, and 12 hours. Okay. Well, 2 will go like right here. 8 is in between the 6 and 9, closer to the 9, and then we have 12. Oh, and 4 goes about right here. So 780, this is sort of hard. When they're not very big, it's hard to get everything into that little spot, isn't it? So let's do hours. They want 2, 8, and 12. And we know that we have 4 is 780. Well, let's figure out how much it is for 1. 4 divides 4 once, 4 divides 780 once, 4, 38, 9, 195. So 2 times 195 will give you 390. 8 times 195, 1,560. And 12 times 195 is 2,340. Now we graph it. 2 is at 390. It's going to be, I'm going to guess it's about right here. 8 is 1560. 8, 1560. It's about right there. 12, 2340. Okay. Yeah. Now, is there a direct variation? Yes. And it is 195 is your direct variation. Now, if it's miles per hour, 195 is miles is hour, so I want 195 on top and 1 on the bottom. So it's 195 over 1 is my direct variation. And it means, what is it? And explain what it means.
195
Miles in 1 hour, right? We're not going to take time to write that down. All right. Now, building on the essential question for today. How can you determine if a linear relationship is a direct variation from an equation, a table, and a graph? Well, for an equation, y equals kx. If it's an equation, your k is your direct variation, right? So your direct variation is the k. In the table, the y to x ratio is constant. So in a table, you have your y to the x, and what you would do, you write a ratio, y to x ratio makes the constant. And then on the graph, it goes through the origin. In a graph, it has to go through 0, 0. I spelled graph wrong. G-R-A-P-H. G-R-A-P-H. Yeah. Goes through the origin, which is 0, 0. Okay? Any questions? All right. Now, what are we going to do for our homework? We're going to do all of page 85. You have 30 minutes, so we have a lot of time. Page 85, all. Turn the page. On this page here, okay, we want to practice writing those. Let me do number 9, do number 8, definitely. Let's do number 9 so you know how to do 10, 11, and 12. If y varies directly with x, write an equation for the direct variation, then find each value. Okay, so y equals k times x. All right, now if y is 14, what does k have to be? What times 8 will equal 14? Well, you're going to do 7/4. You divide both sides by 8 to get your k, and that equals 7/4. 7/4 equals k. Do you see how I solved that equation? This is your you know, y equals kx. That's your direct variation equation. So, where did I get the y? If y is 14 and x is 8, I end up with 14 equals k times 8. Your job is to solve for k. What will undo multiplying by 8? Dividing by 8. And 14 over 8 equals 7/4. And you can just keep it like that. Now, if x is 12, then you're going to have y equals k times x. Here, find y when x is 12. Y equals, we know it's 7/4 times 12. Well, how do I know it's 7/4? Because I found that in this one. I found out that my k is 7/4. So, 7/4 times 12 equals 4 divides 4 once, 4 divides 12 3 times, 21. So y will equal 21. Do you see? Okay, keep this up, and then I want you to do 10, 11, and 12. I'm not going to make you do 13, 14, and 15. So do 8, 9, 10, 11, and 12 on this page, and then turn the page, do all of page 87. It's not that many, really. Page 87 all. All right. Now, if you will work with a partner and you work, you're not playing around, you're not talking about funny things or not funny things, you have to work with a partner. This is something when you talk about it, it's easier to understand. It's not hard, but these are all vocabulary words you don't understand. So I'm going to let you work in partners. Let me turn this